Good morning to all. Let us continue with orthographic projection. Today we will deal with circular surfaces, how to visualize and draw circular surfaces. For that, let us consider a cylinder. So here, this is the cylinder what I have drawn. And assume that observer is here, denoted by X. So this surface is the circular surface. Now if I ask you how many edges a cylinder has, so the popular answer is infinity. But it is not so. What do you mean by an edge? So the definition of an edge is change of surface. So whenever you find a change of surface, it is called as an edge. Example, if you look at this eraser, okay, so this is the flat surface. From this flat surface, you're turning to the next flat surface. So wherever both the flat surface meet, it gives rise to an edge. So this is that edge. So the definition of edge means change of surface in engineering graphics. So if you look at this diagram, for a cylinder, there are two edges. This one, called as circular edge. It is sometimes also called as a rim, RIM. Because this is that edge where there is a change of surface. So this surface and the round surface, they meet each other. Similarly, on the rear side of the cylinder, you will find one more edge. So if I ask you from now onwards, how many edges a cylinder has? So you should say there are two edges. Okay, both are circular edge. Infinity is not the correct statement as far as graphics is concerned. Now if you try to view the cylinder from multiple directions, let us look in the front side. In the front side, when you project this, you will find a circle. Okay, now try to understand the cylinder from the top. So if you view the cylinder from the top, then you can see this circular surface. But up to what extent you can see? You can see up to this boundary. So as you view from above, and if you drop parallel rays of light, you can see the circular surfaces. The circular surface can be seen, but not throughout, up to a certain boundary. So when you look in the top view and try to visualize, the rear circular edge will be seen as a straight line. So I'm drawing a line over here. So actually this line represents a curved edge. The edge is a curved part, but it seems to be straight. Similarly, this boundary of the cylinder will be seen as a straight line. There is one more boundary on the other side that you can say is one more straight line. And finally, the front circular edge will be seen as a line, closing line like this. So that is how a circular surface is seen as a rectangle from the top view. Now what is this I have drawn? Big dash, small dash. It is called as the axis of the cylinder. It is called as the axis of the cylinder. Similarly, if you try to view the cylinder from the side and if you project these points, so try to view from the side. So from the side, this circular edge will be seen as a vertical line. So I have drawn a vertical line like this. You can see the top boundary of the cylinder and the bottom boundary. So you can see two boundaries. Finally, this rear circular edge is seen as a vertical line. So from here, a vertical line will be seen like this. Now whenever you see a rectangle, and if I don't show you the other diagrams, then the confusion lies over here whether the surface is flat or circular. So in engineering graphics, whenever you find a rectangle with an axis line, big dash and small dash, you have to understand that it's a curved surface. So rectangle without axis line means a flat surface, and rectangle with axis line, it means it is a curved surface. So that is how a cylinder is seen as a circle in one view and rectangle in other two views. And wherever you draw a circle, you have to support that circle by a center line. What is a center line? You have to mark a small plus sign and extend by a big dash on all the four sides. Okay, now suppose if I drill a circular cavity, let us drill a circular cavity into the cylinder. What are the changes in the view? So first of all, in the front view, you will find a circle. So I have drawn a circle like this. But in the top view and side view, you cannot make out whether there exists a cavity or not. And we know that the surfaces which are not seen in a cylinder or in any object is shown by hidden lines. And hidden lines are nothing but broken lines. So in the top view, you cannot see this circular surface. So what we need to do is, in connection with that, we need to show broken line like this. So what does this broken line implies? What does this broken line implies? It implies that there is a circular cavity going in throughout. So the distance between these two lines, distance between these two hidden lines, represents the diameter of the circular cavity which is going inside. Similarly, if you look in the side view from here, you will find broken line here, that is hidden line here, and another hidden line will be over here on this side. So both the hidden lines represent that there is a circular cavity which is going in throughout. So that is how a cylinder is represented. I hope the views are clear, and when we proceed with, you'll understand much more better about circular surfaces. So let us start with the second part of orthographic. So here you have an object and you're asked to draw front view, top view and left hand side view. So in the question, they may sometimes not mention from where you have to draw front view, but you need to understand by looking at x direction. So the x direction implies you're supposed to stand here and view along this side. So this is your front view. So our first job is to decide the maximum length, maximum height and maximum width of the object. So if you stand along x, you can make out that the maximum length is 90. So I'll write down here L is equal to 90. Next, you need to find the maximum height of the object. So from the diagram, this dimension is given as 28 plus you need to add this 20 more. So height is 28 plus 20, that gives you 48. Next comes the width of the object. So if you look in the side, the width of the object is 50. So width is 50 millimeter maximum. And you're asked to draw left hand side view, which will be on the right side. So you're supposed to draw front view looking from here, top view, and left hand side view on the right. Okay, so that are the multiple views what we're supposed to draw. Now if you look at the diagram, you will find that in this diagram or in this object you have flat surfaces. So this is the flat surface. You have inclined surface. See, this is the inclined surface. Then you also have circular surface. So any object is made up of these three type of surface. Which are those? Flat surface, inclined surface and cylindrical surface. So we need to start one by one. So step number 1 is to reserve space for drawing these three views, front view, top view and left hand side view. We know the length, height and width. So accordingly, let us start first preparing the box. So all of you first need to clamp the paper with the cello tape. So only two tapes are sufficient on diagonally opposite side. That is sufficient to hold the paper. Now first, we should be aware that whenever we draw orthographic, front view should be drawn somewhere here. Top view is drawn exactly below the front view, and left hand side view is drawn on the right of the front view. So front view, top view and left hand side view, as we done in the previous case. So let us start preparing 3 box. What you can do now is you can mark an arbitrary point over here. Here you can align this bigger ruler and you can draw a light line. So light lines are very important. You need lot of practice for light lines. Second, I need to draw a line perpendicular to the initial light line. That is what I have drawn. So I have drawn 2 light lines, as you can see here. So once the light line is ready, we need to now reserve space for front view. So front view comprises of length and height. So you can see length can be drawn here and height is drawn vertical. So we'll mark 90 over here. Okay, and height of the object is 48. So from this point you can come down by 48. So as I told you, plus minus 2 mm error is allowed. So that can be followed. Now parallel to this line, I need to roll and draw light line from here which represents 90, and parallel to this horizontal line you may lift and roll down to draw height 48. That is how I reserve space for the front view. Do you remember the safe gap between two views? Yes, it is 20 mm. So mark 20 mm from here. Again align the roller scale with the previously drawn line, and then from here you can draw a light line. So that is the gap between the two views. Now comes top view. If you can recollect, whenever you visualize top view, you have to imagine a swimming pool where you can see the length of the pool and width of the pool. Depth cannot be seen. So as per the question, width of the object is 50. So from this point you need to come down by 50. So from here we will mark 50. Okay, then we can align the scale, roll down, and we can draw a line like this. So that is how we have reserved space for the front view and top view. Now what is left is side view. So for side view, from the corner of the front view box, see this is the front view box. From this corner of the front view box you need to draw 45-degree line. So align the scale, align the protractor over here, and from here mark 45-degree. Okay, so once you mark 45-degree, you need to draw a medium dark line so that it can be understood quickly. So this is the 45-degree medium dark line. Now for side view box, wherever this 45-degree line cuts the width of the object, see this is the width, first point, and second point is here. So wherever this width intersects 45-degree, you need to transfer that points up. So from here so that is how I have transferred. So this line has not come. We'll draw again. Yeah, so now you can see this is the width of the side view box. So, sorry, this is the reservation for the side view box. Okay, so that is how the 3 boxes are ready. Okay, now to begin with, there are some important tips what you have to follow. Number 1, whenever you find a circular surface or a cylindrical surface, you draw that view from where the cylinder is seen as a circle. So in this diagram, if you look at this cylinder, you can see it as a circle from the top view. From front view, if you look along X, this cylinder won't be seen as a circle because you can see this circular surface as a rectangle. But in a top view, you can definitely see this circle. Okay, so the hint is that for this cylindrical surface, you should start with the top view. I'll tell you the reason why as we proceed on. So let us try to draw both the circles. So if you look at the diagram of the object, there are two circles, inner and outer. The outer circle diameter is 30 and the inner one is 20. So let us try to locate the center of the circle from the top view. As far as dimension is concerned, let us see the center of the circle. So see, this is 50, 20, total is 90. So the balance has to be 20 because 50 plus 20 plus 20 is 90. So the center of the circle is 20 millimeter inside. But if you observe thoroughly, the other dimension is not specified. So whenever the other dimension is not specified, you have to assume that the cylinder is centrally spaced. For example, this is 50. If you take half of 50, 25. So from there you can locate the center of the circle. So let us start locating the circle first. So this is the top view box. I will take half of 50, 25. Okay, so this is 50 millimeter, 10, 20 and 25. So from here, I'll align the scale. Okay, I will lift and roll. I will draw one light line. So this is the axis of the cylinder where it should lie. Now inside you have to move by 20 because it's given here 50 plus 20 is 70, so balance has to be 20, or you can take 70 from behind, it doesn't matter. So let me mark 70 from behind. If you want to avoid addition subtraction, you can mark 70 from behind. So I'll mark 70 from behind like this. Now, so this point is the center of the circle, and we need to draw two circles, diameter 30 and diameter 20. So this was the compass what we are going to use. So first we'll draw the outer circle. So for that I will take half of 30, 15. So I have set 15 in the compass. Now because circle is an object line, you need to draw it dark. So that is how I have drawn the circle dark. So this is the outer circle of dia 30. The inner circle is 20. So radius is 10. So I need to set 10 millimeter. What I do is I always take the scale, place the scale upside down to get a better grip, and then I mark 10. And here so that is how I have drawn two concentric circles with the help of a compass. Now once the circle is drawn, you may discontinue with the top view and you can start with the normal front view. Okay, now why we have drawn circle first, let us see. Suppose if I don't draw circle first and if I draw a rectangle and then when I project, it is possible that after you project and when you draw the circle by compass, the circle might not touch both the projectors. It happens many times that when you take a compass and start drawing circle, it intersects one line and doesn't intersect the other line. So it is always advisable to do other way around. You first draw the circle and then project both the points up for drawing the other view. Anyway, let us start with the front view now. In the front view, when you look along X and if you compress the object against the wall, you can see two surfaces A and B. These are the two surfaces what can be seen, A and B, as a one single surface. Okay, Apart from this, you can see the circular surface C as a rectangle. So these are the three surfaces what can be seen in the front side. Let us start with A now. If you look at A, you can see a dark line of 90 mm long. Then you can see 20 mm long line upward, and on this side it is 12 mm upward. So let us first draw these three lines. So to begin with, first we will start from here. Those lines should be drawn dark, so double trace, left to right, right to left. Then 28 mm up you have to move. So from here we'll move up by 28. Yes, that is what we have done. On the other side we need to move up by 12 mm. See, this height is 12. So here we will be moving up by 12. Now look at this dimension. This dimension, either you have to leave 50 from behind or you have to mark 40 from here. So let us mark 40 from this side. So I will align the scale, slide up. Okay, so let me, yeah, so 10, 20, 30, 40. So 40 till 40 mm I will proceed for the double trace. So always keep on double tracing. Okay, object line. Now very important part, in the question this dimension is not specified. This length is not specified in the question. Neither this inclined edge length is specified, neither angle is specified. What students do is that they make suitable assumption. They say that this looks like a rectangle or looks like a square. So if this is 30, even this is 30. So that assumption is wrong because they have nowhere specified that this is a square. So it's a wrong assumption that this is 30. Neither this inclined line is known, this length is unknown. So unless you know this length, you cannot proceed. That is where students get stuck up in engineering graphics. So how will you determine this length? Or how will you determine the angle of the inclined line? How to do that? So for that, little logical thinking is required. When you compress the object against the wall, try to visualize when you compress the object against the wall, this inclined surface together will be seen as a one single line. See, if you combine this edge and this inclined edge together, it will be seen as one single line. So instead of trying to hunt for this line, why not locate this point in your book? I have prepared a small model for you to understand. See, this is that object. Okay, so I tried to prepare an object which looks alike. So this is that object over here. When you look in the front view exactly, you'll realize that this edge and the rear edge together will be seen as one single line. So if you want to find the length of this line, you won't get directly. So first you need to draw a continuous line till the top, because this inclined surface is one single surface. So therefore in the front view, when you compress the object against the wall like this, okay, when you compress the object against the wall, you will find that this is one single surface. Okay, so that is how the object looks like. So let us try to hunt for the topmost point, which is 18 mm from here. So in this diagram, I will mark 18 mm. Let me mark a point 18 mm. In fact, I'll darken it right now. And then I will connect this. All of you should be aware, instead of 18 by mistake, sometimes you mark 12. So while marking, you should be aware that you have taken 18 and not 12 by mistake. Okay. Now this 20 mm edge will be seen dark. So that, okay, before that, now the length of this line can be easily found. What is that? So the length of this line should be extended to cut the inclined surface. And you know that this line is parallel to length. So parallel to 90 mm, if you draw a line to cut the inclined surface, you get the length of this line. See how it is. So this is our length 90 mm. If I extend this up and if I draw double trace and draw a line like this, so this length, which you can obtain only after drawing, you cannot obtain by any calculation, it can be done only through drawing, has been obtained now. So this 20 mm vertical edge can also be seen as a line. For that we need to close this here. So that is how surface A and B both are ready. I hope it is clear till now that in the front view object appears like this. Let us now focus on surface C. So if you look at surface C, it will be seen as a rectangle. Okay. So for that, try to visualize this diagram. You are the observer. Now see, this is the top view, right? See, this is the top view. And observer is looking from this side. So when you look from this side, or if you turn the object, that is what you get in the front. So in the front view, that is how the object will be seen. And if you drop this down, this is the top view. So observation is from this side, that is what you have to visualize. And when you look at the cylinder, it will be seen as a rectangle. So this cylinder will be seen as a rectangle in the front view. In the top view, it will be seen as a circle. Okay, front view, rectangle, top view, circle. So right now you are looking from this side. So when you look from this side, you can see this part of the cylinder. You cannot see the other part. So it is like the sun and the earth. For example, the observer is here. So this is the source sun. So when you look from this side, only this part gets illuminated. The other part is in dark. So only this half of the cylinder will be seen. Okay. So because this half will be seen, you need to project this here. And this part, just a second, let us, this part will be seen like this. So I have projected the diameter of the cylinder here. Okay, because you can see this half as a rectangle. What is the height of the cylinder given in the question? It is given as 12 millimeter. So from here, you have to mark 12 millimeter. So double trace and darken it. Even here, and then close this. So that is how the cylinder is seen as a rectangle. Correct? So that is the front view. Once again, let us observe. Yes. So this cylinder, this rectangular portion is this one, what you can see. And in the top view, this is how it appears like. Okay, now comes a very important point. See, below the object, there is a slot. A cutout is there. The depth of the cutout is 5 millimeter. 5 millimeter is the height of the cutout and width is 30. So when you look in the front side along X, you cannot see this cutout, which is 5 millimeter high. But the depth of the cutout is not mentioned in the question. And one very important thing I am going to discuss now is, whenever the depth of a cavity or the slot is not mentioned in the question, you have to assume it throughout. And when I say throughout, it means it should come out from the other side. So this height is how much? 5 millimeter. Even if you look at this object, see, there is a slot at the bottom. Can you see this slot? There is a slot over here. So the side you can see it correctly. Yeah, so you can see that there is a cutout over here. And that cutout is throughout. Okay, so you cannot see this slot. So this slot you cannot see from the side. And that is 5 millimeter above. So that represents a hidden surface. You have to mark 5 millimeter here. Align the scale. And neatly you have to draw the cutout now. So you know that you have to double trace, because hidden lines should always be double traced. And you have to hold the scale firmly, because if the scale moves, hidden line will not be in a straight edge. You may get zigzag lines. So to hold the scale very firmly. And as per the rules of hidden lines, you have to see that the ends of the hidden line should intersect the dark line. Okay, so that is how the hidden lines are drawn. Okay, now there's one more thing left in the front view. The last thing what is left is, in the front view, you cannot see this circular cavity which is going inside. By mistake, student assume that the depth of the cavity is 12. See, if the depth of the cavity was 12, you could have seen the inner edge, right? But it is not so. So again I repeat, whenever the depth of a cavity is not mentioned, you have to assume that it is throughout. And throughout means it should meet another cavity. So if you look at thoroughly, the depth of this cavity should be such that it should meet this slot. So if you look at this particular model, the depth of the cavity should be such that it should come out from here. It is still the slot surface only. Okay. It cannot come out beyond the slot because there is no material. So it should be till slot surface only. So that is how the cavity depth is mentioned. So here when you draw the cavity depth, so I'll align the scale like this. Okay, let me slide behind. And from here you need to draw hidden line such that it should intersect another hidden line. See, like this till here. Same way here also. So from here, if I draw a hidden line, so the depth of the hidden line should be such that it should meet another cavity. Cavity cannot extend beyond this because there is no material. This is the slot. Now as I told you, whenever you draw a rectangle without axis, it means it's a flat surface. But this is not a flat surface, it's a circular surface. So what we need to do is, we need to draw medium dark axis line. So medium dark axis line means it's a combination of big dash and small dash. And now see, be careful. See this axis line I have drawn, right? It should extend from the cylinder from both the sides. So slightly should come out from here and also from here, because the dotted line also represents a circular surface. So there are two circular surfaces, the outer one and the inner one. So the length of the center line should extend the longest circular surface. So that is how the front view is complete. Let us now start with the top view. So when you look in the top view from here, so observer is here. You have to stand here and look in the top view like this. So you can see the first flat surface of 1 over here. The second flat surface is on this side. The third flat surface over here. Let the cylinder be the fourth one, and that we have already drawn. Apart from this, if you observe thoroughly, you can also see some portion of the inclined surface. So if you look here in the top view exactly, you can see this inclined surface. But the question is, will this inclined surface be seen as exact shape or reduced shape? Yes, it will be seen as reduced one. And in engineering graphics, reduced means apparent. So you can see the apparent shape of this inclined surface. And actual shape means true shape. So there are two technical terms, true and apparent. True means exact, apparent means reduced. So in the top view when you observe, you can see this as surface 1, right? Then this rectangle will be seen as surface number 2. You can see this in and around the cylinder as surface 3. Fourth, let it be the circular surface. And fifth is this inclined surface. So we need to draw this one by one. So first of all, let us see this first part, what I am writing here, number 1. Let this be number 1. And when I turn like this in the front, over here, so what we can say is, this line represents the first surface. Correct? So if you see here, this is first one. In the front view, surface 1 is seen as a line, and that line is over here. Then you can see the second surface over here, and that surface is on this side. So in other words, whatever you see in the top view as a surface, the same thing in the front view is seen as a line or an edge. So this edge is nothing but it represents surface 2, and that is what I have drawn here. Surface 3 is where the cylinder is kept. So that this line is surface 3. In exam you no need to mention 1 to 3. This is just for your understanding. Okay, now as we discussed before, while drawing you need to start one by one. So let us start with surface 1. So this surface 1 over here, this is the surface 1. When you turn like this, that surface will be seen as a rectangle and it is kept somewhere here. The position of that 1 is here. So what we should do is, the length of surface 1 we need to project from front view into the top view. So for that we'll align the roller scale. We will roll it and draw a light line. So that is how this represents surface 1. But what about the width of surface 1? So go back to the question. You have projected 18 from the front, right? So the width is now 20. So we need to mark 20 from here. Okay, and we will darken the rectangle. So I have darkened the rectangle over here. So let us darken this from all the four ends. This will give us surface number 1, which is seen as a rectangle. So the surface 1 is ready. Now comes surface number 2. The length of surface number 2 is already ready over here. So that is what is orthographic is. In orthographic, you need to identify the various surfaces in multiple views. So in the front view, surface number 2 has to be identified like this. And then you need to align, roll and project this down. Okay, so if you observe and look at this diagram here, surface number 2 width is 30. So see, out of 50 here utilize 20, so the balance is 30. So here when you draw that surface 2, we just need to align like this and darken the rectangle what comes out after projection. So you have seen that we have drawn surface 2. So once again, if I place this model, surface 1 is over here, surface 2 is over here. Inclined surface we will draw at the end because that you are going to get automatically. Let us cover this box to give us surface number 3. So surface number 3 is from here to here. So surface number 3 length is from here to here. So we need to project that length down. So let us do that. So I will close this rectangle from all the sides so that I'll get surface number 3. So that is what I have done. Surface number 3 is ready. Finally, what is left is the inclined surface. So if you look at this diagram, this is our inclined surface, right? So this edge, if you try to look in from the front and identify this edge in the front view, so that edge is this longest length. So it is from here to here. And when you project that length down, already projected, and if you close this box, so see, this part represents the behind edge. Isn't it clearly visible? Similarly, if you look at this edge, it is a smaller edge and the lower one. So the smaller edge and the lower one, when you project both the lines down, you will find the missing edge over here. So when you connect them, this L shape is your apparent inclined surface. So see in the top view. Okay, so this, what you can see is your apparent inclined surface. Same thing is over here, apparent inclined surface. So that is how top view we have completed. Like, the only one important thing left is when you look in the top view, you cannot see the slot running down. See, there's a slot which is being cut. That cannot be seen from top view. It means in the top view, this edge which is going inside, first and second over here, both these edges cannot be seen. Have you noticed one thing? Whenever you find two lines intersect, it is obvious that a third line has to pass from that corner. So each and every object is made up of a corner, and corner should have three edges: length, width and height. Similarly, if you look at this corner, you will find two edges. One is moving up along the height, second is along the width. So obviously the third one has to be along the length, which is not seen. So in the top view you cannot see both the edges. And if you look at the measurement 50 minus 30 by 2, or you can say from center, take half of 30, 15, 15, you'll get that edge. So from here, I will mark 15 up and 15 down. So 15 up and 15 down, and I will draw a hidden line. So when you draw the hidden line here, remember you need to intersect the dark line as well as you need to double trace it. So neatly you have to show hidden lines, double trace, length should be more, gap should be less. And finally you need to make it to intersect here. Then roll this up, and from here, okay, you need to show hidden line. Now in some cases what can happen is, some of the students when they draw hidden line, it is possible that this hidden line may not touch the circle in some case, and in some cases the hidden line intersects the circle. So what I want to say is, while drawing this hidden line, suppose the hidden line doesn't intersect the circle, then also it is acceptable. So it is not compulsory that the hidden line should touch the circle. But if you look at geometry wise, see the diameter of the outer circle is how much? 30, and even the slot is 30. So logically they have to intersect, but because of drafting error sometimes it may not intersect. Then also is okay, it is acceptable. So that is how the complete top view we are drawn. So what does this hidden line represents? It represents that there is a slot which is passing below the object, and these are the two edges which you cannot see from the top view. That is the meaning of this hidden line. Before I end with the top view, one thing what is left is, whenever I draw a circle, it has to be represented by center line. So as you have shown the cylinder here by axis line, you have to show by center line. So mark a medium dark plus sign, and then by scale you just need to extend this on all the four sides. So that is how the cylinder is ready along with the complete top view. Okay, now comes the side view. So side view we need to visualize from this side. So you can see this C type surface. Let us first draw the inner C. The height of the inner C is 5 mm and width is 30. So remember, height you will always get from the front and width from the top. So side view is the combination of front view and top view. The front view will always give you the height and top view will give you the width. So height of this slot is 5 mm. So you have to identify where you have drawn 5. Yes, the 5 mm is this hidden line. So by roller scale we need to project this here. And width is 30. Width means top view. So in top view both the hidden lines are 30. So extend till 45 and project it up. So I'll extend this up to 45 degree, and then I will extend this up. So now we can darken these three edges. First, second and third. So this is the inner C what is being drawn. Okay. Similarly, we have the outer C. Outer C height is 12 and width is 50. So 12 mm where we have drawn? Yes, it is this height. This is 12 and 50 is the total width. So this 12 mm I need to project in the side view. So I'll extend this here. Okay. So let me darken this. I'll bring this down. So very simple. Orthographic is a very simple topic. Whatever you see, you have to draw. So you can see this C type connected here. So that we need to connect it like this. Yeah, so once this is done, let us now proceed quickly. Now look in the side view. In the side view, this inclined edge will be seen as a vertical line till the top. So by observation, this edge we need to extend till the top. So that is what I am doing here. Okay, now this dimension is 20. If you try to measure 20 over here, then you won't learn orthographic. What you do is that this edge 20 millimeter, it belongs to width of the object because this is along the width. See, 50 is width. So this is along the width, and width you'll always get from the top view. So to learn orthographic, you should try to understand where is this width in the top view. Try to recognize. So in the top view, this same width is over here. See this one. If you keep your scale, even this is 20. So this 20 we need to transfer it in the side view. So like this, we need to transfer. We need to transfer this in the side view and darken accordingly. Say like this. After that, you need to come down by 20 millimeter. So 20 is nothing but height. And where will you find height always? Yes, in the front view. So in the front view, this is 20. So extend this line 20 mm and darken till the required part. Later on, simply by observation, you need to close these two lines. So here we need to close the first line and here the second line. So the major part of the side view is over. The only thing what is left is the cylinder surface, which is 12 mm height. So what is the side view of the cylinder? Will it be seen as a circle or a rectangle? Yes, it will be seen as a rectangle of height 12, and height is always found in the front. So in the front, this height is 12. So from here we will project this. So 12 mm is ready. But what about the other position? Now see, little common sense, this is 30, right? And even this is 30 you are drawn. So if I just darken the required part, I can get that 30 mm. So now the last thing what is left is you cannot see the circular cavity which is going in, and the depth of the cavity is till the slot. How much it is? 20 mm. So in the diagram, if you look at top view, you already drawn 20 mm ka circle. So extend this till 45 and let's see what can be done further. So extend it till here and then also on this side. So that is how this dotted line represents that there is a cavity going inside. Finally, you can mark half of 30, 15 because as I told you, whenever you find a circular surface, you have to show axis line. So big dash and small dash axis can be shown like this. So this is the complete side view of this object. So if you look in the side, from here. So from here, if you look in the side, that is how the object looks like in the side. Okay. The last thing and very important what is left is the dimensioning. So we need to show 10 to 12 important dimensions covering length, width and height. So first of all, length is 90. Length is 90. So we can show length here. How to show length? From this dark line, leave a space of 2 millimeter. Draw medium dark extension line. From here 2 millimeter, draw extension line. So why I should leave space? So as to make out the difference. And here you have to show dimension 90. So here I will show dimension 90 over here. So neatly you have to write 90. 90 should not touch the dimension line. So this is called dimension line and the vertical lines are called extension line. So after 90, height is 28 and 20. So let us show in the side view 28 and 20. So to always spread the dimension in all the views. So this is 28 and 20 is over here. Okay, so let us, so uniformity is more important. Neat arrow marks. So you have 28 and 20 over here. So that is how we have shown height 48. Now width. You can see from here 30 and 50 width can be shown together. Okay, so we can show 30 here. So first smaller dimension always followed by larger one. So leave 2 mm gap and show extension line. So here this is 30 and this is 50. So to show dimension 30 and 50 over here. So length, width, height and over. Now very important dimension I am going to show. How to show dimension for a circle? Let us learn that. So see, whenever you want to show diameter like 30 and 20, you have to always show at that place where you have drawn the circle and not the rectangular part. So to show the dimensions for cylinder, wherever you drawn a circle in that place. For example, here you need to draw a line outside at 45-degree angle as you can see, and another line perpendicular to it on the opposite side like this. Now for the outer circle, show arrow mark pointing the outer circle like this. See, arrow mark should be on both sides of the circle, and here you have to show the inner circle, correct? So that is how the arrow mark should be shown. So if I enlarge a little, yeah, so that is how arrow marks are shown for the outer and inner circle. And then from here you just need to draw horizontal line and write 530 neatly, on the other side 520. So that is how you have to show dimension for a full circle. It's compulsory to show like this. Both the lines should be perpendicular to each other like this, and arrow mark should point the inner circle and outer circle. Okay, hope it is clear. So total dimension, if you count 1, 2, 3, 4, 5, 6, 7, we can show 3 more. So for that, in the front view there is only one dimension, so we can write this 18. So in the front view, this 1, 2, 3 there is no need to show. And remember, all the light lines you have to retain. Do not erase any of the light lines. So here this dimension is 18. This dimension is 18, and so this dimension is done. Okay, height of the cylinder is 12, so 12 can be shown here. So we can show 12 like this. So that is how dimensions are shown. Always show dimension above the line. See, this is called above. Look at 90, 18, 30. Look at this 28, it is above. Okay, so above means when you turn the line, dimension should be above. So these are the standard way to show dimensions. So you can see this 12. I think it was hidden. You can show this. You can see this 12 over here. Okay, so that's all for today's session.